This is the first problem in the probability review for the final exam. So let's look at what's given here. The measure here is time in months since a student had his or her last cold. So the measure is a quantitative variable. The measure here is time, and the corresponding probabilities are given. So the first row gives us the range of values starting from 0 up to 3. Any number is a possibility. So what this first row says is that the probability that a student had their last cold in less than 3 months is 0.34. Now the next row is a range of values starting from 3. So it starts with 3 and goes up to 6 but not including 6. And the probability that a student had their last cold within the range of values 3 to 6 months is 43% or 0.43. So any number between 3 and 6 is a possibility. So the measure here is a quantitative variable that is also continuous. It is not discrete because a discrete variable can be listed. So you could have 0, 1, 2, 3, 4. If you have a list, then that would be a discrete variable. So that answers our first question. The variable here is a continuous variable because any real number greater than 0 is a possibility. So if you look at the last range of values, it is anywhere from 12 onwards. So starting from 12, it could be anything, which means it goes up to infinity. Basically, that is done to cover all the possible values. Now the part B, the question says, assuming that it is a legitimate probability distribution or a valid distribution, can we figure out the probability that it has been 12 months or more since the student had the last cold? So if it is a legitimate probability, so let's go through quickly the steps of a legitimate probability distribution. All outcomes are listed, so you can see clearly that nothing is left out. It covers everything from 0 to infinity. So anyone can answer a question with any number, and that would be included in this sample space. So it goes anywhere from 0 to infinity in a measure of time. And so all outcomes are listed, and clearly there is no overlapping of outcomes here. Less than 3 and then including 3 up to 6, not including 6, and then the next step includes 6 and goes up to 9 and so on. And clearly if you look at the list of outcomes, then you'll see that there is no overlap. So all outcomes are listed. There is no overlap between outcomes. All probabilities are listed. Assuming that this is a legitimate distribution, the sum of all the probabilities has to equal 1. So when we add up the 4 numbers or 4 probabilities that we have seen here, that are given here, it goes up to 0.98. So 1 minus 0.98 is the probability that a student had a last cold in 12 months or more. So 0.02 is the probability that fits into that legitimate probability distribution. And just make sure that the calculations are correct by adding all the numbers, making sure that the probabilities add up to 1. Next we look at part C. The event is given by x lies between 3 and 9. In this case, x is a measure of time in months. So the time that is measured here is anywhere between 3 and 9 months. So it could be just anything from 3 to 9. So X, the amount of time that we are measuring that a student got a cold, is between 3 and 9 months, including 3. That's exactly what it means. So here, every real number is included. Since the variable is continuous, we are not just measuring the whole numbers, we are measuring everything between 3 and 9. Now, if you need to figure out the probability, the letter P here means measure the probability. Here, the first part of the question just says describe the event. So next we're going to figure out the probability. So from the table, anywhere from 3 to 6 months is of probability 0.43, and anywhere from 6 to 9 months, not including 9, is 0.20, which is 0.20 probability. So it could be this or this. So if it's going from range, it ranges from 3 to 9, then it could be from 3 to 6 or 6 to 9, which means we add the probabilities. In any table of this sort, usually you're adding probabilities. So the sum is 0.63, and that's the probability that X lies between 3 and 9 months.